Hello everyone, myself Hariom Mehta. I am currently pursuing my masters in physics from Indian Institute of Technology, Jodhpur. So today we will discuss about the relative motions, specifically relative motion in a straight line. So let's begin our discussion. So relative motion, okay? Relative motion in straight line. So as we study in the class 9 that what is the straight line motion, so it's very simple that when the body is moving in particular in one direction only, then this motion is called the rectilinear motion or straight line motion or one dimensional motion also. So here we discuss about the relative motion in the straight line motion. So first I would like to take an example that let's say there is a moving bus which is moving with the velocity of 50 kilometer per hour, and there are two passengers inside it. Let's say A and B. Okay, this is A and this person is B. And there is third person which is at the ground and observing the bus. So this is the C. So according to this C, A and B are both are moving with the 50 kilometer per hour. But there is when A observe B, there is no movement in the B. Means when A is observed, B is at the rest. But when C is observed, then B is moving with the 50 kilometer per hour. So from here we can say that the rest and the motion are the only relative term. Means that depends on the relativity. They are depends on the other, so they are the relative to each other. Okay, so rest and motion both are the relative term. And we can also see that this is the, because when C observed the B, this is the moving with the some velocity, but when A is observed B, there is no motion in the B. So here we can say that this is the combined property of, means there is the property of the observer and the objects only. Means where object is being observed or by whom it being be observed. So from here we can also say that the rest and motion are the combined property of object which is the B here and the observer. So there are two observer here, one is C and one is A. So according to A, B is at the rest, and according to C, B is moving with the some velocity which is 50 kilometer per hour. So these are, so how we decide these? So from here we can say that there is a frame of reference. So there is one frame of reference of C and there is another frame of reference of A and B, which define it's moving with the some velocity and this is standing. So what is the frame of reference? Frame of reference is nothing but the set of coordinates which is used to determine the position and the velocity and the acceleration, etc. So this is the frame of reference. I am not going too deep into the frame of reference. So let's begin with the another term, relative displacement. So what is the relative displacement? Okay, so let's say take three peoples one, there is the referral people, means observers, which is named as A, and there is two more person are here, which are at some distance, B and C. So according to A, B is at the XB position or XB displacement from the A, and according to A, C is at the XC positions or XC displacement from the A. Because A is our origin point, so we no need to say this. Means this is a subscript. I would say that when B, when this type of written, then the position of or displacement of B with respect to O, or when it's written like this, then this is the displacement of C with respect to O. So this is the method of the written, means how to write notation, nothing but it's notation. So we would like to calculate the displacement between the B and C. Okay, so how this depends on, so displacement of B with respect to C is nothing but the, from here we can say that the displacement of C minus displacement of B. So displacement of C, yes, this na okay, displacement of C minus displacement of B. Okay, so displacement of B with respect to C is the displacement of C minus displacement of B. So this is our relative displacement formula. We can easily calculate the position or displacement with respect to C, and also we can calculate the displacement of C with respect to B, which is x of B minus x of C. How it comes? So see there that when, because the displacement is directional dependent, so when it's take its negative, so negative it, when the negative sign is there, so it's turn into this. Okay, मतलब ये इसमें आ जाता है. Okay, so from here relative displacement we can easily calculate the relative velocity. So let's see how we can calculate the relative velocity from here. So okay, this is the relative displacement. Okay, so how we can calculate the relative velocity from here? Relative velocity. Okay, so what is the velocity? How we define the velocity? Velocity is the nothing but the dx by dt, means displacement upon time. As we know that the time is independent of the frame of reference, means when the velocity is the very, means in Newtonian mechanics, time is the independent of the independent from the frame of reference. When we go for the higher study, there is the some relativity concept comes and time is dependent also. So as of now we are consider time is independent from the frame of reference. Okay, so let's say V of B C. Okay, so when we means let's take a point, this is the B and this is moving with some velocity, and this is also another person which is C, which is also moving with the some velocity. Okay, so from here we can calculate the velocity of B with respect to C. So velocity of B with respect to C is equal to the velocity of C minus velocity of B. And the when we try to find out the velocity of C with respect to B, which is nothing but the opposite to it. So V of B minus V of C. How it comes? So from here we can see, we can easily derive this term when we put let's say when with derivative of this term, when take out the derivative of the whole term, then this gives this term. Okay, so easily we can derive from here to here. So and also we can derive for the relative acceleration term, when we can easily put the derivative with respect to time, then this term is for the acceleration, relative acceleration. Okay, so these are the our three formulas. So now take an example for this. Okay, let's say B and C both are the moving with some velocity, okay, in same direction. Let's say this is moving with the 5 meter per second and this is moving with 10 meter per second. And this velocity is the with respect to the ground, okay. So we have to calculate find the velocity of the B with respect to C. So our formula is the velocity of C minus velocity of B. When there is subtrahend is missing, then this always is the with respect to the ground, okay. So what is the velocity of C with respect to ground? This is the 10 meter per second. And what is the velocity of B? Then this is the 5 meter per second. So what is the velocity of B with respect to C is nothing but the 5 meter per second. Okay, means when B see the C means जब B C को देख रहा होगा तब C is moving with the 5 meter per second with the velocity of the 5 meter per second, means they is moving with the 5 meter per second. Okay, so this type of problem they are. Let's consider there is another problem. Let's say B is moving with the 5 meter per second in opposite direction, and this is B and this is C, which is moving with the 10 is it's 5 meter, this meter per second in opposite direction. Let's just see. So from here we can calculate the velocity of B with respect to C is nothing but the velocity of C minus velocity of B. But take care of one thing, that velocity of C is positive, okay. This is on the same direction because we consider this is the positive direction. So velocity of C is 10 meter per second, but velocity of B is the opposite to the our positive direction. So we'll consider is the negative. So this is now 15 meter per second. So now the velocity of B with respect to C is 15 meter per second. So that's all for today. Thank you.